This class relates to product and service strategy. Now clearly the type of operation is directly related to the product and the service strategy. Clearly the type of product determines the type of organization, and it also determines the operations within the organization. It determines the type of production that will take place, or the type of service that will be produced. So the type of product and service determines the operation, determines its structure, and determines its operations, determines what happens. Three basic strategies include make to stock, in other words, produce the item and put it into the stores in anticipation of future sales. So the product is made in anticipation of sales. It's not made to order, it's made in anticipation. So make to stock. The next is to assemble to order. So it's built from standard components on order. It could be the company produces some of the components and puts the components into stock, and then when an order arrives, assemble from the stock of components in the stores. It's really a halfway between make to stock, the first one, just make the item, complete it, put it into the stores and wait for orders to come in. It's midway between that and the other extreme, which is just in time. Just make the product when the order arrives. So assemble to order, it's like it's half done. The components may be produced, put into the stores, and when the order arrives, they are assembled. The final part is make to order, produce to customer specification at the time of the order. So it's a question of waiting for the orders to come in and then producing. So there are three strategies: make to stock, assemble to order, and make to order. We can identify make to order with some simple examples. For example, if somebody wants a suit made, may go and see the tailor, and that's made to order. The suit is made for that person. It's customized to that person. Some suits may be made to stock. Some suits may be produced and put into stores and brought out as and when required. These are the non-customized suits. Now, product and service strategy options. Well, the production strategy options, for a start, if we look at it in terms of delivery time, well, made to stock. Well, make to stock means processing, assembly, and product inventory. Then the item is shipped or delivered to the person who's placed the order. So if it's in stock already, then the processing, the assembly, and all of the associated functions have already been completed. It's waiting in the stores. So it's a question just of shipping it. So the time for delivery, the lead time for delivery, is just the shipping time. So the lead time is as indicated, just the shipping time there. And that's made to stock. In other words, the items come out of the stores and are just shipped or delivered to the customer. There is no assembly, there's no processing. All of that's done in advance. Now the next type is assemble to order. In this case, there is processing, and that's the processing has been done. There is product inventory. Well, that's been done. Now it's a question of delivering the item to the customer, but assembling it before it goes. It's assembled to order. So the delivery time is longer than made to stock. Made to stock, it was just the shipping time, so that was the delivery time. Now the delivery time is the shipping time plus the assembly time. The items are taken out of stores, the components, and they're assembled, and then they're packaged up and shipped out to the customer. So the delivery time is much longer in this case. It's got the delivery time has got the assembly and the shipping. Now the made to order, well, there may be some inventory, some items kept in stock. These are very generic items which may be kept in stock. But here the item has to be made. The item has to be assembled. It has to be processed. And then it has to be shipped. So the delivery time is much longer in terms of made to order. So if we look at the whole diagram, the made to stock, the top one, the delivery time is just shipping. The next one, assembled to order, well, the delivery time is the assembly time plus the shipping time. So it's much longer. And made to order is the longest of all. The delivery time between when the order is placed and the item is shipped to the customer, that is the longest, because the item has to be made, then it has to be assembled and processed and checked and quality and so on, and then it has to be shipped. So that's the longest delivery time. Now the degrees of vertical integration and make or buy. Well, vertical integration refers to the degree a firm chooses to do processing itself, say moving from raw materials to sales. So companies that are highly vertically integrated will start with raw materials and work their way right up to customer delivery. So they will do everything in between. They will do the processing of the raw materials, the acquisition of the raw materials, the processing within the company, finally the delivery to the customer. So all aspects of the product is dealt with internally. The company is called vertical. It's vertical because it does everything from raw materials right through to sales. Backward integration means moving closer to primary operations. So backward integration means the company may make some product, but it may also have control over the raw materials and over components and so on backwards. It's moving back towards raw materials. That's backward integration. Forward integration means moving closer to the customer. So a company may be forward integrated if it's producing an item, but it's also looking after shipping, delivery, perhaps even after sales service, looking at customer satisfaction and dealing with customers. So it's producing the item and it's also dealing with the customers. So it's forward integrated. So we have two types of integration. Wherever a company is, it may be backward integrated, in other words, moving back towards raw materials and the acquisition of raw materials and components and so on. So it's making more and more of these itself. It's backward integrated. Forward integrated means moving closer to the customer. So the company may make the item but also have outlets on the high street selling the product. A firm's make or buy choices should be based on the following considerations. On the strategic impact that the make or buy decisions have. How will they influence the strategy of the business? Now, make or buy means the company makes the product itself, or it buys in components, or it even buys in the product and sells it on. But it buys in components, let's say, and assembles the components. So it may buy in processed parts, or it may make them itself. But clearly, as to which route it takes must be linked to its strategy and what it wants to do. It also may be linked to available capacity. The decision to make or buy, in a sense, may be out of the hands of management. They may not have the capacity to make the various products, the various components that go into the products, I should say. So they may not have that capacity. They may not have the floor space or the machinery or the expertise. Or it may not simply be economic to make those. It would require such an investment in capital, and given the amount required, it would not be financially justified. So the make or buy decision really depends on the available capacity as well. In addition, the company must look at its own expertise. What are its core competencies? What can it do best? What are what are the skills within the business? And what is the pattern of skills within the business? How are the skills being developed, and what skills do the operators possess? What would they need to possess if they were to make the various components themselves? Again, the question is, would it be worthwhile training the operators and buying in new equipment to make components when they can be purchased elsewhere, perhaps competitively purchased elsewhere? There's also quality considerations. Once the item is within the remit of the business, once the item has been produced within the business takes responsibility for the quality of the product. And the components, therefore, will have to be checked for quality before they're assembled into the product for delivery to the customer. Quality, as I've suggested many times in many videos, quality permeates the whole organization. It runs right throughout the organization, every department, from start to finish. So quality considerations would have to come into account, would have to come into play as well. And also the speed with which the items can be produced. Machines might have to be tooled up, and raw materials may have to be acquired, and people switched over roles, and there may be considerable management issues involved in just getting those items produced, whereas if they're bought in, someone else had that responsibility. So in terms of costs, there may not be a lot of saving to produce in-house, particularly if the item is complicated or specialized, and specialized machinery required and specialized expertise on the part of the staff. There are issues about quality and checking quality, the available capacity, and it's the speed with which they can be produced may be a problem. And cost, as I've suggested a few times in just discussing this particular set of points, cost would have to include the fixed cost. There'd have to be an apportionment of the fixed cost set aside for the area of the business taken up by this extra production, plus the variable cost, the cost of making the good, and that must equal at least equal the fixed cost and the variable cost of buying. So if it's the case that buying it is cheaper when those cost calculations are made, then why make the product? So the rational solution may be to buy in the components and assemble them, not necessarily make them from scratch. Technology decisions. Well, there's a problem about the degree to which the whole industry, or the industry in terms of the wider context of industry, the degree to which industry is becoming mechanized and hence more competitive. Because of the mechanization, there may be cost savings, and this will put this decision down to individual companies, who will then have to look at how to use information technology and how to use robotics and computing power to their advantage. The problem with this is having the skill to do it, having the know-how to find and then implement these very sophisticated processes may be an issue. Normally what happens is businesses try to simplify their processes. They try to simplify what they're doing and then apply the appropriate technology. So try to make the tasks clear and then try to buy in the technology, get it implemented and get it set up, and then apply it, then use it. But on the basis that each particular function is quite straightforward. There's less opportunity for failure and for things to go wrong. There's an area called enterprise resource planning, and it's looking at the appropriateness of technology within the business. It's looking at where technology is best suited, the types of software that are available, the types of functionality that the products would have to have, and try to match these to the requirements of the company. It's not just a question of buying sophisticated computing power and then underusing it. It's also not the case of buying sophisticated computing power but not buying enough of it. So it does require a great deal of thought and a great deal of expertise as well in setting it up and getting it running and reaping the benefits of it. Automation is something which has become more and more talked about in industry over probably the last 20 or 30 years. And certainly it's been applied in many cases where there is continuous production and perhaps cheap items mass produced. And we've seen on television, we've seen in many examples where there is automated processes. Machines are specially customized to produce en masse. The problems with automation is that it can be also inflexible, and if it breaks down or it has a problem, it's difficult to put it right. But having said that, the benefits of having machines working to very close tolerances, to very tight tolerances, and having machines doing quite sophisticated work and doing them at speed and doing them perhaps 24 hours a day continuously, the benefits of that are enormous. So it's natural that companies will look towards automation as a solution towards cost saving, perhaps improving quality, and just to have an overall control of the business. But it is inflexible and it does require expert maintenance. So it's not free, and perhaps also it's not that cheap. There's also automated material handling, perhaps automated guided vehicles in large stores. What used to look like forklift trucks now are automated guided vehicles, and they can go and pick the quantities that are required, the types of goods that are required, and they simply follow lines in the floor, or they may be even GPS guided, depends. But they are very accurate and they work independently. So automation is creeping in at a very fast pace, I should say. There's also the need to look at flexible manufacturing systems. And by this it means the ability to be able to switch between one type of manufacturing system to another, produce the same item but switch over, and also to bring in different machines or different components into the production process when they're freed up elsewhere. So in other words, there's overall flexibility in the use. Generally speaking, the machines that can be switched over easily tend to be the more generalized machines. Highly specialist machines tend to be inflexible, as do highly specialized personnel. Workers who have very high degrees of specialization cannot be used perhaps widely within the organization. They're most effectively used in areas to exploit their expertise. So flexible manufacturing systems have benefits because companies are able to draw on capital which is standing idle or underutilized, and staff which are perhaps underutilized. But bearing in mind that the type of capital that's most appropriate in that calling in process, the type of capital is probably more generalized type of machinery, not the highly specialized machinery we were talking about earlier. There's also robotics and numerically controlled equipment. Robotics became popular mostly with images from the car industry, with large robotic arms doing spot welding and doing it to a very fine tolerance, and also very fast and very efficient. Spot welding is not the most interesting job in the world. It can be very boring, and it's very dehumanizing as well. If somebody works as a spot welder, they're essentially doing the same job day in, day out. And that wears people down. They get bored, there's a high degree of absenteeism, they want to move on. Robotics, in a sense, solves that problem. It does the continuous processing, and it does it very accurately, and it never complains. So there's been the introduction of robotics right throughout industry where possible, and there is the constant seeking of opportunities to introduce robotics where possible as well. E-manufacturing. Well, web-based environments create numerous business opportunities to include product design collaboration, for example. It's possible for design engineers right across the world to deal with each other very efficiently because of the advances in communications. So as communications has become better and also more secure, they're able to teleconference and send drawings and messages and discuss issues, and it's a much more efficient way of producing. And the impact of this type of communications on design in particular cannot be understated. It is very important, and it's particularly important because many businesses have branches overseas, and with the whole process of globalization, this has become quite important. There's also process design collaboration. It's not just designing the product, but having designed the product, they have to design the processes that will go to make the product. And specialized products will have, generally speaking, quite specialized processes. They will need certain machinery, they will need certain expertise. And the web-based environment enables engineers and managers to share experiences and to solve problems and look at issues and communicate effectively so that there is a continuity in production, and the choices of processes and products are well thought out in advance. There's also computer-aided design. This has come a long way. It's been used right back to the start of computing almost. There were quite primitive packages, but at the time they were state-of-the-art, of course. But now it's possible to design items and look at the materials used and look at the issues associated with the materials in the context of the stresses that the product's going to undergo, but also to get a design which will ensure that it's error-free, that if components are inserted and they don't fit precisely or there's a mismatch, the software itself will highlight the issues. In the past, it would have to be made and it would have to be tested. There would be prototypes of products made and then tested. It's now possible to almost get rid of the prototyping and do it all through the computer by looking at very advanced graphics and looking at the engineering involved. And many CAD packages, computer-aided design packages, are so sophisticated that they can highlight issues or problems even before it's made. Computer integrated manufacturing. This is the integration of product design, process planning and manufacturing using integrated computer system. Well, computer integrated manufacturing gives managers, gives shop floor engineers and managers, gives top management, gives branches overseas all the opportunity to feed into what is the correct process, what should be made, how should it be made, how should it be manufactured, what materials should be used, how should it be scheduled. And computers have come to the rescue in taking away a lot of the hard work here. So there is more use of computers, and the computers, in a sense, guide the business, they guide manufacturing. They're able to discuss, or not discuss, to highlight, that's a better word, to highlight raw materials requirements, deliveries, shipments, quantities, and then progress the raw material through the whole manufacturing process to shipment at the end. Designing services, or how do they differ from manufacturing? So let's look at services. They're different from manufacturing as they produce intangible products. So services we can't touch. They are services produced for customers. They may range from accounting services, legal services, there could be medical services. There are all sorts of services that we can conceive of. And what they've all got in common is that they are intangible. We can't touch the service. With a manufactured product, we can pick it up and look at it and rotate it and drop it on the floor. But with a service, we can't do that. It involves a high degree of customer contact. Services and customer requirements are linked, and linked totally. The customer must specify what he or she wants, what sort of service it is, what they expect at the end, and then the service is delivered with that in mind. With manufacturing, the customer is really only involved at the final stage, perhaps the purchase stage. Companies try to integrate customers into the advice and use them as focus groups and give opinions about the products and marketing and so on. But really, the real impact of the customer is at the point of sale. Whereas with services, the customer is involved all the way through. And the type of service is classified according to the degree of customer contact. The more contact the customer has, then in a sense, the more it is a service. So if we have a haircut, then the hairdresser or the barber or whoever will be involved with us while we're having the haircut. There's a high degree of contact. For some services, there may be less contact. For example, the production of final accounts for a business. Once the records have been handed over to the accountant, there's no need for a great deal of contact after that. Designing services. Well, service characteristics. We have pure service, we have quasi-manufacturing and mixed services. Well, pure services, 100% service. There's no technology in the sense involved, or not much involved perhaps. You're dealing face to face with somebody. Quasi-manufacturing is that in-between phase where there are people involved and machines. Artisans, for example, will be providing a service, perhaps in providing some unique product or some unique piece of art or whatever it is. But they may also be using some machinery. And it's quasi-manufactured, it's half manufactured, or there's an element of it which is manufactured. And we also have mixed services. It could be that a company offers a variety of services to its customers. The service package, well, we have the physical goods, we have the sensual benefits. When we think of the physical goods, we think of the pleasure, in a sense, we have out of possessing those goods. So if we buy a new car, then it's the sensual pleasure, the fact that it looks good. The car looks good. It has good functionality. We have a psychic reward for purchasing the car, and that may be what drove the sale in the first place. And these, in a sense, overlap with the psychological benefits. We demand products for a certain reason, and that reason is because they give us satisfaction. Now, differing designs will substitute technology for people where possible. That may apply. Some items enjoy the status of telling the customer it was made by hand. Shoe manufacturers, specialist shoe manufacturers, the item was produced by hand. But businesses, generally speaking, try to find ways of using capital where possible because it's labor saving and therefore cheaper. Some try to get customers involved. Shoe manufacturers sometimes try to identify who buys the shoes and then follows up with emails and asks about the shoes and asks about the satisfaction associated with the shoes. And some companies try to involve customers also in an advisory capacity through focus groups or through questionnaires or open days. Try to get customers involved and try to have customer attention, try to get a good degree of customer attention on the product so the customers can let the business know what their feelings are about the product and what changes would be welcomed and what are the issues associated with the product, the broad issues. So we see here that in terms of the three we just got, the labour intensity is upwards. The service characteristics, pure services, that's pure labour intensive. There are no machines there. Working our way down towards substituting technology for people and so on, we have more and more capital and more technology as we move down from 1 down to 2 down to 3. So customer contact, well, if we turn this into a diagram, then we'd have quasi-manufacturing down towards the origin. It's low labour intensity because it's quasi-manufacturing, warehousing, transport, that sort of thing. Low customer contact. Mixed services, well, offices and that sort of facility. And pure services, schools, hospitals and restaurants. So we can, using the labour intensity axis and the customer contact axis, we can classify different companies according to their labour and customer contacts and intensities. So pure services, for example, schools offering a pure service. The teacher teaches the class. Hospitals, doctors, look after the sick and the ill. Restaurants offer food. It's a service. And at the bottom, transport, well, very little contact with the train driver when we get a train, usually no contact with the train driver, and it is a low level of labor intensity. The driver is one person, and the machine and the train can be very long and have many carriages, so low level of labor intensity. So we can imagine classifying businesses according to that schema. Now, product design and process selection across the organization. Well, strategic and financial issues associated with product design and process selection mandates operations work closely across the organization. So there's the constant pressure on businesses to look for the most efficient ways of manufacturing, most efficient ways of making the product or delivering the service. So there's a constant drive to look at the product design. What is the product? How can it be changed? How can it be modified? How can it be streamlined? And also looking at the appropriate processes that are needed to make that product design. Clearly, the more complex the product is, the more processes will be required. If the product is very straightforward, fewer processes. But there's a trade-off. Perhaps customers want a sophisticated product, in which case there's going to be a lot of processing. If the customers are happy with just something very simple, then it would be easy to make. But then lots of issues creep in about if it's easy to make, then there's very little to protect the business against competition or against trade from outside the country, because the product is so easy to make. Perhaps the barriers to entry are associated with complex products, which are difficult to copy and difficult to produce. Marketing is impacted by a product that's produced. Marketing and the marketing strategy must be related to the product. And the more sophisticated the product is, on the one hand, the greater is the barriers to entry, as I just said, but also the greater the problems that marketing have in answering questions and providing information and allaying fears on the part of the customers who see the product as complicated or technically advanced, and some may be put off by that. Finance is integral to product design and process selection issues due to frequent large financial outlays. So a complex processing system may require more investment, it may require more training for operators, it may require more maintenance for the machines and specialized parts. So finance is clearly related to the process, the product process, and to the product design. More sophisticated products, more complicated products take longer to produce and to design, and there are financial implications associated with that. Now, product design and process selection across the organization. Well, strategic and financial product designs and process selection, these have to be taken into account, as I said, by the organization. And information services has to be developed to match the needs of the production process. It's important that information is available to management. It's important that information is captured at different stages in the production process and fed back to the appropriate personnel for analysis and for perhaps subsequent decisions and alterations. So the more complex the product is, the more complex the process is, and the chances are the more information that's going to be collected and needs analysis and will need decision. Now, this may be facilitated by sophisticated software packages and so on, but it still means that someone has to analyze it and make decisions which, if the product was simpler, would not have had to be made. So there are financial issues and personnel issues indeed. The appropriate people must be in place to make those decisions and to monitor the whole process. If the item is straightforward, a straightforward design, a simple design, and therefore requiring simple processes, it's less costly, but also there's less involved in terms of training and there are less chances of mistakes. The downside, as I said earlier in the previous slide, is that type of product lays itself open to international competition, and it may mean that any profitability, any good profitability associated with the product will be competed away. Human resources provide important inputs to the process selection decisions for staffing needs. It's important that people are taken into account when looking at the design of production processes. It's important that people's opinions are sought. Sometimes operators on the shop floor will see problems and issues that perhaps are not obvious from a higher perspective, from looking at it from above. So involving personnel across the organization in the decision is a good idea. More precise comments about what's likely to go right and go wrong may be picked up as a consequence of their involvement. So the summary, well, product design is the process of deciding on the unique characteristics and features of a company's product. Process selection is the development of the processes necessary to produce the product being designed. So we have a linkage here, a linkage between the product design and the processes that are needed to make that product. And as I said earlier, a simple product may require simple processes. A complicated product, more processes. And there are issues associated right throughout the organization as a consequence of that. Financial problems about more complex production, more complex machines, more training. It may be that there are HR problems in terms of training and making sure that there's health and safety, and make sure that the staff are motivated to produce this extra layer of complexity. So there are many issues that cut right across the organization, and these all go back to the product design. Steps in product include idea generation, product screening, preliminary design and testing, and final design. That's how products come about. They start with an idea. They start in someone's mind. Then they start to take shape, some drawings, some sketches. Then there's a series of products that are proposed, all related around the same idea. There's product screening takes place to see which one is most likely to succeed. Then there's a preliminary design to see what it would look like, and perhaps some testing. It may be put onto a CAD package and investigated on the CAD package, moving towards a final design. And all the time, departments like marketing will be feeding in to this whole process and informing the business what customers think and what the customers are looking for and what sort of feedback they're getting from customers. In the meantime, the business must look towards its own operators and the operations side of the business to see what issues are likely to be encountered if such a product was produced. What are the staff requirements? What are the training requirements? And also they should look at budgets to make sure that it can be financed. But there are many areas to be looked at when considering product design. Break-even analysis is a tool used to compute the amount of goods that have to be sold just to cover costs. That's dealt with in separate videos, but it is an issue that it's important that when products are being dreamt up, when products are coming into the stage where it's likely that they're going to go forward for manufacturing, that the managers have an idea of how many of the products they need to make in order to break even. How many do they need to sell? And the marketing department will be asked to provide some indication of likely sales of such a product. Production processes can be divided into two broad categories: intermittent and repetitive operations projects, to batch, to line, to continuous. So we can look at intermittent demand for products, and intermittent demand will lead to intermittent production. So the processes may not be continuous, in which case it may be slightly more expensive to produce, but the company needs to tool up for the product from time to time, but it is selling. It's selling the item. A more repetitive operation is where it's more continuous. The production is more continuous, therefore it's somewhat cheaper to produce. It depends on the nature of the product. Sophisticated products, by and large, tend to have more intermittent demand and more intermittent operations as a consequence. Product design and process selection decisions are linked, and that's one of the important conclusions that we've come to, that product design and process selection are linked intricately. The issue is that product design, the complexity of the product, determines the complexity of the processes, and out of that flows the implications for finance, personnel and marketing and so on. Process flowcharts can be used reviewing the flow of the processes involved in the production, in producing the product. Flowcharts are useful. They're representations of what needs to be done and the various stages, so that there is something of certainty about the whole production process. And particularly with a complex product, it's important to be able to produce a flowchart to show what steps need to be taken next and how the steps are linked. Different types of technology can significantly enhance product and process design. There's all sorts of technologies that can be built in: CAD, computer-aided design, and flexible manufacturing systems, computer integrated manufacturing, and there's lots of software available to help in this process. Some of the software will require an expertise in itself, and the people using it will have to be specially trained to be able to deal with that. But the benefits of having these technologies are quite considerable, and they may show up faults or issues even before the item is produced. Sophisticated CAD packages, as I said earlier, can now indicate areas of conflict within the product where components don't fit smoothly together or they're mismatched in some way that would probably not have been obvious in the past. So there is a drive to use technologies where possible and try to reap the benefits of the technologies. Designing services have more complexities than manufacturing because service production is intangible, and typically there's a higher degree of customer contact. So services can be quite tricky. It's not a standardized production process. An accountant dealing with the accounts of a business, when the accountant moves to the next business to do their accounts, there'll be a different set of figures and a different set of circumstances. So it relies on the skill of the accountant to be able to move from one set of accounts to the next. So there's more contact with the customer, and it's more complex, and there's less opportunities to go for the benefits of computer-aided design or CAD packages, or there's less opportunity. Well, there's no opportunity for these. So it is down to the accountant and to the accountant's skill. So what we've done in this session is we've looked at product design and process development and tried to draw out the fact that the two are linked. And if I was to summarize the whole session in one sentence, that's what we've done. We've shown that product design and process development are part and parcel of the same thing. They are, the product design determines the processes. The more complex the product, the more complex the processes. But that's all I'm going to deal with in this session, so I'm going to leave it at that and say thank you for watching.